Let's solve problem 5.14 for Microelectronic Circuits 8th edition by Sedra and Smith. Consider an N-channel MOSFET with T sub box equals 4 nanometers, mu sub n equals 450 centimeters squared per volt seconds, threshold voltage of 0.5 volts, and W divided by length is equal to 10. Find the drain current in the following cases. So before we just start tackling this problem, I think there's some preliminary information that would be helpful to discuss first. So we need to consider two cases for each of these problems. MOSFET devices will either operate in the triode or saturation region. So in the triode region, that occurs when the voltage from drain to source is less than the overdrive voltage. And then into saturation region, that occurs when the voltage from drain to source is greater than or equal to the overdrive voltage. And in each of these cases, we'll have to calculate the overdrive voltage. It is equal to the voltage from gate to source minus threshold voltage. So you'll see it'll be different for each case. Now, if we're in the triode region, then the drain current is equal to K sub n times voltage from drain to source times overdrive voltage minus 1/2 times the voltage from drain to source squared. In the saturation region, drain current is just equal to 1/2 times Kn times V overdrive squared. And you see for both cases, we need to find the value of Kn, so let's go ahead and take care of that. So Kn is equal to mu n times Cox times width divided by length. So we're given our value of mu n, and to make sure I take care of units correctly, I'm going to convert these all to standard units. So we're going to convert centimeters squared to meters squared. So that's going to be 450 times 10 to the negative 4 meters squared per volt second times Cox. C sub ox is equal to epsilon ox divided by Tox. And epsilon ox is just a constant for silicon. It is 3.45 times 10 to the negative 11, I want to say farad per meter square. Yeah, or no, just farad per meter. Yeah. Divided by T sub box. It's 4 nanometers, and I want to convert that to just meters, so 4 times 10 to the negative 9 meters. And then W divided by L is 10. So Kn, I'll get 3.88 milliamps per volt squared. So now we're ready to solve case A. All right, let's begin with case A. We have VGS equals to 1.8 volts and VDS equals 1 volt. So I'm going to start by calculating the overdrive voltage. It's equal to VGS minus VT, which is 1.8 volts minus 0.5 volts, which is 1.3 volts. And VDS is equal to 1 volt, which is less than our V overdrive. So therefore, in this case, we're operating in the triode region. So we can calculate current as not 1/2. Sorry. Wrong equation. So it'll be Kn times VDS times V overdrive minus 1/2 times VDS squared. So that is 3.88 milliamps per volt squared times VDS is 1 volt. V overdrive is 1.3 volts minus 1/2 times VDS, 1 volt squared. So I get a drain current of 3.88 104 milliamps. Okay, let's do case B. Once again, I want to start by solving for V overdrive, which is a voltage from gate to source minus my threshold voltage, which is 0.7 volts minus 0.5 volts in this case. So V overdrive is 0.2 volts. VDS is equal to 1.5 volts, which is greater than V overdrive. So in this case, we're in the saturation region. So our current can be calculated as 1/2 Kn V overdrive squared. So that's 1/2 times Kn, which is 3.88 milliamp per volt squared, times V overdrive squared, so 0.2 volts squared. And I get a drain current of 0.0776 milliamps. 0.0776 milliamps. Okay, let's continue with case C. All right, let's keep going. So for case C, I'm going to calculate my overdrive voltage again, which is VGS minus VT. So for case C, we have 1.8 volts minus 0.5 volts. We have 1.3 volts. And VDS is equal to 0.1 volts, which is less than the overdrive, so this has to be the triode region. Okay, so I can calculate my drain current to be Kn times voltage from drain to source times V overdrive minus 1/2 times the voltage from drain to source squared. So drain current is equal to 3.88 milliamps per volt squared. Just parentheses there, times VDS is 0.1 volts. V overdrive is 1.3 volts minus 1/2 times VDS, 0.1 volt squared. So I get a drain current of 0.485 milliamps. Let's round it off with part D. So we have V overdrive is equal to VGS minus VT. So once again, it's going to be 1.8 volts minus 0.5 volts, which is equal to 1.3 volts. Our VDS is equal to 1.8 volts, which is greater than V overdrive. So we are in the saturation region. So we have a drain current of 1/2 Kn V overdrive squared. So 1/2 times 3.88 milliamps per volt squared times V overdrive of 1.3 volts squared. Okay, I get 3.28 milliamps. 3.28 milliamps. And that rounds off the problem. Thank you very much for watching my video. For any comments or video suggestions, feel free to contact me in the comments or by my email. And I hope you have a great day.